Welcome students. Let us study different approaches for synthesis of nanomaterials. All the synthesis methods of nanomaterials can be classified as either a top-down or a bottom-up approach. These are the two main approaches by which nanomaterials can be synthesized. They are exactly two opposite approaches. The synthesis of nanomaterial from bulk material can be generally called as top-down approach. For example, high energy ball milling, ion sputtering, ion arc discharge, etc. While the synthesis of nanomaterial from the basic building blocks such as atoms or molecules is called bottom-up approach. For example, chemical vapor deposition, Solgen method, hydrothermal method, co-precipitation, templating methods, etc. That is, there are two main approaches, top-down or bottom-up approach for synthesis of nanomaterials. These two approaches of synthesis can be schematically represented like this. Top-down approach in which the synthesis is done from bulk material up to nano-sized particle material. Bulk means big size material and this is the nano-sized material. We know that nano-sized material means the particles having the size between 1 nanometer to 100 nanometer. That is the particle size of nanomaterial. And from bulk to nano-sized particle, that method is known as top-down method or top-down approach. While the synthesis from atoms or molecules up to nano-sized particles, that approach is known as bottom-up approach. Thus, there are two main approaches, top-down and bottom-up approach for synthesis of nano-sized particles. These are the two approaches, top-down and bottom-up. Top-down approach involves following methods: the ball milling method, electrospinning method, sputtering method, the arc discharge method, laser ablation method. While bottom-up approach, that methods involves chemical vapor deposition, Solgel process, solvothermal and hydrothermal methods, templating methods, co-precipitation methods, etc. First we see synthesis of nanomaterials by top-down approach. The first method we are going to discuss the ball milling method. The ball milling method, it is a top-down approach method. The ball milling method, it is a mechanical process used for production of various types of nanomaterials including nanoparticles, nanocrystalline materials and nanocomposites. In this process, a powder mixture is placed in a ball mill, a container that rotates along its own axis. This is a ball mill which rotates along its own axis. The balls inside the mill crush the powder into small particles and then converts into nanomaterials. It is a simple and relatively inexpensive process that can be performed in a laboratory setting. It offers a high degree of control over the resulting nanoparticle size, shape and composition. The ball milling method can be modified to produce various nanomaterials with different properties. For example, the addition of surfactants or other additives to modify the surface properties of the nanoparticles. This is a ball milling method. It is a mechanical process and which is a top-down approach method. The next method is electrospinning method. In electrospinning method, this method is used for synthesis of nanofibers and nanocomposites. In this process, a polymer solution is electrostatically charged and then drawn out into thin fiber by applying an electric field. This is the schematic diagram. This is the syringe containing polymer solution and electrostatically they are charged. Then such type of nanofibers were deposited on this film. The resulting nanofibers can have the diameters as small as few nanometers. The diameter of the nanofiber can be controlled by adjusting the polymer solution concentration and by the electric field strength. The resulting nanofibers can have high surface area to volume ratio, making them useful for applications such as catalysis and sensors. These nanofibers also have a wide range of applications including biomedical engineering, drug delivery and energy storage. This is also a top-down approach. The another method is sputtering method. In sputtering method, this method is a physical vapor deposition method. In short, it can be known as PVD technique used for synthesis of nanomaterials. In this method, a target material is bombarded with high energy ions causing atoms or molecules to be ejected from the target and deposited on the substrate. This is the target material and it is bombarded by high energy ions and the atoms or molecules are ejected from the target material and that is deposited on the substrate. And there is a formation of a thin film. The resulting thin film or coating can have the thickness ranging from uh, a few nanometers to several microns, making it suitable for a wide range of applications in electronic and optical devices. The sputtering method can be used to synthesize a wide range of nanomaterials including metals, metal oxides and composites. The next method is arc discharge method. This is also top-down approach. The arc discharge method is a physical synthesis technique used for the synthesis of nanomaterials, particularly carbon-based nanomaterials such as carbon nanotubes and fullerenes. This method involves the use of high-energy arc discharge between two electrodes made up of the target material. These are the two electrodes made up of target material, resulting in the formation of nanomaterials. CNTs, that is carbon nanotubes, can be synthesized by using graphite as the target material and adjusting the experimental parameters to promote the growth of tabular structures. The main advantage of arc discharge method is that the synthesis of large quantity of nanomaterials can be done in a relatively short time. This method is suitable for industrial scale production of nanomaterials. The next top-down approach method is laser ablation method. The laser ablation method is a physical vapor deposition technique used for synthesis of nanomaterials. This method involves the use of high energy laser to ablate or vaporize the target material. This is the target material. This is the laser beam by which uh, the target material is vaporized and it is deposited or condensed on this substrate. And we get the nanomaterials here. The laser ablation method can be used to synthesize a wide range of nanomaterials including metals, metal oxides and carbon-based materials. The next approach is bottom-up approach. Synthesis of nanomaterials by bottom-up approach. The first method is the chemical vapor deposition method. In short, it is also known as CVD technique or CVD process. In this case, the gaseous species are allowed to react or decompose on a hot surface to form a solid products. This is a gas precursor. This is the heated substrate and there is a deposition of solid material, that is nanomaterial. The structural purity and the density of the thin film or nanoparticles are higher in this case. Metallic, semiconducting and ceramic materials can be coated using CVD technique. Based on activation sources for chemical reactions, the CVD can be classified into thermally activated, laser assisted and plasma assisted methods. This is a chemical vapor deposition method. The another well-known process is sol gel process. The sol gel process is a little bit it is a cost effective method. Low temperature method mainly used for the synthesis of ceramic and metal oxide powders. The process begins with the development of colloidal precursors known as sol. This is the metal ion solution, that is sol, followed by the formation of gel. Sol solution, that is metallic solution, is converted into a sol solution, it is converted into gel and finally sintered to obtain the final products. The sol gel process is mainly used to synthesize single and multiple component metal oxides. It can be used for synthesis of variety of nanostructures like nanoparticles, nanofibers, thin films, nanotubes, etc. This is the schematic diagram for sol gel process, which is a bottom-up approach. Then next method is solvothermal and hydrothermal methods. For that method, such type of Teflon line steel autoclave is used. When water is used as solvent, then that method is known as hydrothermal. And if solvent other than water is used, then that method is known as solvothermal method. The solvothermal and hydrothermal methods are two commonly used techniques for synthesis of nanomaterials. Both methods involve the use of high temperature and high pressure conditions to promote the formation of nanoparticles. Solvothermal methods typically use organic solvents, while hydrothermal methods use water as the solvent. The solvent can also be influence the morphology, size and properties of the resulting nanomaterials. Solvothermal methods are often preferred when the precursor chemicals are poorly soluble in water or insoluble in water. In hydrothermal methods, water is used as solvent, which has the advantage of being abundant, low cost, and environmentally friendly. That is a green method for synthesis of nanomaterials. Hydrothermal methods are often preferred for the synthesis of metal oxide and hydroxide, as the reaction conditions can promote the formation of these nanomaterials. One of the advantages of solvothermal and hydrothermal methods is their ability to produce nanomaterials with controlled size, morphology and properties. This is the main advantage of solvothermal and hydrothermal methods. Then next method is templating method. The concept of templating involves using the template or a mold to guide the synthesis of material with specific structure or morphology. This is the diagram. The template can be biological entity. That template can be biological entity such as virus or a protein, or an inorganic material such as nanoporous membrane or colloidal crystal. The template is used to direct the assembly of the building blocks or precursors of the material, resulting in the formation of material with a specific structure. Nanoporous templates are porous materials with well-defined pore sizes and shapes, such as aluminum membranes, mesoporous silica, or zeolites. This method is used for synthesis of wide range of nanomaterials, including nanotubes, nanorods, and porous nanoparticles. Such type of method is used known as templating method. Then next method is a co-precipitation method. This is also a well-known method for synthesis of nanoparticles. In that case, there are two solutions. One is cation solution, another is anion solution. These two solutions are mixed together, stirring, followed by precipitation, filtration, washing and drying. It can be shown like this. This is a cationic solution, one is anionic solution. These two solutions are mixed, stirred, and in that case the alkali is added, the pH is maintained, and then precipitation takes place. And after precipitation it is filtered, washed and dried. Then we get the solid materials of nano size, that is known as co-precipitation method. This method is widely used bottom-up approach for synthesis of nanoparticles. This method involves the precipitation of metal cations from a solution using a precipitating agent, followed by the formation of nanoparticles through nucleation and growth processes. The co-precipitation method is particularly useful for synthesis of magnetic nanoparticles, which have a wide range of applications in biomedical imaging, drug delivery, and environmental remediation. One advantage of the co-precipitation method is that it is a simple, low-cost approach for synthesis of nanomaterials. Thus, these are the two approaches for synthesis of nanomaterials. One is top-down and another is bottom-up approach for synthesis of nanoparticles. Thanks for watching this video.